Hi everyone. Before I show you the system that I have built, let me start with why I built it. So I see the problem statement is today a CXO, a CFO, CPO, or CEO constantly switches context. They jump between document systems, dashboards, emails, project trackers, just to answer one question, and that friction is expensive. And my belief is that the primary interface for knowledge work will shift to conversational AI, whether it's Claude, whether it's Team Copilot, or anything enterprise assistant. And the real question is, are your documents ready to be queried intelligently when that happens? So simple text is my answer for that. A private document intelligence layer that sits behind any AI interface and returns grounded, accurate answer from your own documents. So let me show you how it works. So I have document layer, unified knowledge base. On screen, you can see the documents currently there, which are indexed and ready to be searched. And it's a mixed formats. You can see PDFs, Excel, and Words across completely different domains. I have documents from Project JICON. I have documents from biodiversity. I have documents from aviation maintenance manual, scientific methods, and F1's rules and regulation, all sitting in one unified knowledge layer across format and across topics. Now, a little bit on what happens when I upload the document. So I have just started uploading on my screen. I will re-upload something that I have already uploaded. So when I upload, the AI generates a summary for it. Uh, and then I think in this case, the summary is already generated. You can edit the summary, and here I'm just entering author. In future. This will be from the login. Once I upload the document, uh, the indexing happens and in the background, and once the indexing is done, it says the status is ready. So uh, so I will explain a little bit of three types of indexing that happen on the background. The first one is metadata, which is the B-tree indexing, metadata indexing using binary tree. This is what populates this row instantly, document name, type, author, and upload date. This powers instant listing and filtering without touching the document content. Now, index 2 is basically the FTS5, full text search using FTS5. Every word is tokenized and stored in an inverted index. This is your exact match layer, fast, precise, when you know the term exactly what you are searching from. And the third is semantic search, the vector search with HNSW indexing. That is semantic indexing. Every chunk is converted into a 3072 or dimensional vector using Gemini embedding 001 API. This captures the meaning, not the words. Now HNS-W organizes these vectors into a graph, so we can retrieve relevant content in near constant time. By the time status says ready, all three indexes are built and the documents are fully curable. I'll spend a little bit of time to explain the chunking strategy. It's primarily driven by precision and context because this is a search problem that we are solving for, and there are two ways to evaluate search. Either you maximize the precision or maximize the recall. Underneath, we use a parent-child documenting architecture. So the parent chunks are exactly up to 1,000 characters, the full context, and the child chunks are 250 characters, the focus summaries. Child chunks make retrieval precise, parent chunks make answer rich. Child finds the right neighborhood, parent gives you the full script. Now I will show you the search. The fact that I have explained you indexing, now search becomes a little more intuitive. So I'll go to the search bar and I will search for something like protein. Okay. What it gives me is comes back with the file name, location, but I don't get any context, no explanation, no answers. So it finds the word but doesn't understand it. Now let me type something which is a more real question, right? So what happens when and driver cuts a corner to defend position. Uh, no result or no irrelevant result, no result. So it does the string matching, no understanding, no intent understanding, and this is where my ask endpoint will come into picture. The HNSW indexing that we have done, and we have exposed that using the ask endpoint. So if I switch to my Postman, and this is the ask endpoint, and I'm firing the exactly the same question. Now let's see what my ask endpoints returns. If I go to preview, you can see it exactly uh, understood the meaning. The question is converted into a 3072 dimensional vector, a mathematical representation of the meaning, not just word. And next, two search happens in parallel in this. One is vector search, one is the keyword search. A keyword search is just the exact match, and the vector search is the semantic similarity match. Then we do something called identifier fusion. So both result sets are merged and deduplicated into a single candidate sets. Vector might find some documents, keyword might find other documents. The fusion just ensures you don't miss anything and we don't duplicate anything. Then comes the context retrieval. For each unique result, we fetch the full parent chunk and reach surrounding, which I explained in the parent-child chunking strategy, right? Then we pass everything to a re-ranking, the flash rank, re-rank result using cross-encoder. So it runs locally. It's not a API call. It goes each passage against the question and retrieves top three passage. What is the endpoint returns is a grounded context, no LLM involved yet to translate that particular context into a meaningful answer. So retrieval is happening here, retrieval first and then reasoning later. Now I'm going to show something interesting, which is like I'll go to Claude Desktop and I will just ask, I will just check here whether my simple text is connected. So what we have done is we have exposed both of these API, the ask endpoint and one more endpoint, which is about the listing of documents that's there inside my knowledge hub. And we have exposed this in MCP servers.py. Then we have also changed the Claude desktop configuration so that the connectors actually appear here in the cloud setting that you have seen. If you click on the plus icon and go to connector, it's saying simple text is connected. So let me just verify whether it's connected or not. Are you connected to simple text? So it says, yes, I am connected. I can see your enterprise knowledge hub, and it just has two tools, list documents, and then the ask semantic search. Um, and now I'll probably rerun the same question that I have in my Postman. Uh, so this is basically the chance where everything that's getting retrieved by the ask API you in the end, after the flash re-ranker, that's getting passed to my Claude, and Claude to translate that to a meaningful answer so that it would be very meaningful for the end user who is running it, right? It's running the ask endpoint round and it's providing the results. Here, the full rack pipeline runs, retrieves context, plot generates answer, no form of training data, no form of the web search. This is retrieving everything from my uh, um, document hub, right? And let's just test the other endpoint and to make sure this is truly agenting, because I'm not telling him which tool to use. It just reads the tool description and takes the decision that okay, I need to use a list document tool or search tool. So what documents have I uploaded to simple text? It correctly now picks up the list documents tool, and it just lists down everything in a double. These are the documents I have uploaded to my simple text. So because I uploaded one document 3 times, it's correctly flagging that one also out as part of the demo. Also, I uploaded. Now we'll do something more interesting, which is basically whether we have sufficient guard for hallucination. So if I ask a question which is probably not there in my knowledge base that I'm very sure of, what is the salary of the project icon PMO director? So picks up the right endpoint. It's a specific question. Uh, and it then doesn't hallucinate. It searches and it didn't find. So the prompts are written in such a way that if it doesn't find, then it should not answer. It gives the right answer that knowledge hub don't contain any salary information. The PMO is governed by Vikram Rathod, but his compensation details are not part of the uploaded project documents. The budget tracker is there. For salary information, you need to check with your HR department or a payroll system directly. So it just proves that there is no guessing, no fabrication. That's hallucination uh, resistance, right? Now I'll show you a little bit of my evals, what I have done. So we didn't just build this, we have validated it. So there are 3 types of queries if you see. Simple factual query, which just involves one document to answer that question. And then I have multi-hop reasoning, which requires multiple documents to be queried to find out the answer. Crosstalk is where more than 2 docs are involved. And then the negatives are primarily the hallucination card. And if you see the scoring, the scores are basically for all simples. We got the scores as 5, and multi-hop we got 5. For crosstalk also we got 5, and for negative we got 0, which is right. For negative your models would correctly refuse. um, 6 question answered perfectly, and 3 hallucination blocked completely. So it's accuracy plus honesty. Now I will take you through my architectural snapshot. So uh, the stack is basically fast API backend, Chroma DB for vector search, SQLite with FPS5 for keyword and metadata, then the Gemini embedding, Flash re-rank for local re-ranking, MCP server for agent integration, then LLM judge to evaluate the results. So that's the eval framework. Every component is deliberate and every decision is visible. I've also written everything in detail in a document, which would be very easy for you to just go through without looking into the code and understand what each endpoint is doing and how the UI is connecting to a backend, and this is probably evaluation more detailed. Also, I have estimated a cost a little bit using the models that I am using. And now that I'm going to close it, I'll just talk a little bit about um, what's coming next and what we have seen. So what we have seen is a hybrid retrieval, vector plus keyword, parent-child chunking, identity fusion, local re-ranking, agentic tool selection, and system that is basically measured and validated. What comes next? This is just model 1, a working document intelligent foundation. Now we scale it further into enterprise-grade AI layer, right? So what I'm currently working on is a bulk multi-document ingestion, folder level uploads, drag and drop reports, parallel indexing like a queue-based processing. And then I will also work on the agent memory, a stateful intelligence. So my session should have summary, long-term user memory, follow-up understanding and stitching context across queries. Then I will also build a multi-agent router from single tool to a orchestration kind of thing. I already have a little bit of a single agent multi-tool router, but can I have kind of a to A structure to solve complex use cases? Now, uh, finally, I will build something like to retrieve analytics and observability. So from black box, you can actually should go to a measurable system. The foundation for that is already done. If you see, I have something called a granular performance CSP. So we are basically tracking everything that happens. So when is B2 indexing starting, when it is ending, everything is done over here. So the analytics layer, I believe, would be simple because we have the data. We just need to present the data in such a way that it's more meaningful to someone who is reading. And the last one would be a little bit on governance and security, role-based access control, document level permission, and then attribute-based filtering, little bit of audit logs and isolation of tenants. And finally, we'll work a little bit on the graph layer beyond the documents. Can we have relationship mapping, graph-based querying? Then we'll work on a little bit on a full platform level deployment, like a Docker containerization or a one command setup, cloud plus on-prem support. Uh, Mainly containerization is the primary goal, and scalable infra, maybe a plug and play type of platform. And we'll look into a little bit into integration. Can we integrate this across all um, tools, right? Like Teams, Slack, email, BI tools, document system. And yeah,